1906 was really the first time that scientists realized that earthquakes were caused by movement along faults. They'd certainly known about earthquakes for generations, and they'd known about faults too. They'd seen them, but they thought they were caused by something different. They thought that they were old, past, ancient things, not something that would be able to cause the type of movement that we saw at the surface of the Earth. 1906 also taught us something else about the movement. And it has to do, of course, with the spirit of Californians. So let's say you have this property here, and you have this fence, and there's the fault that has moved and torn your fence in two. What do you do as a Californian? We rebuild! But there's a problem. Where do you rebuild? Of course, your fence is not only designed to keep your cow inside your yard, but it's also supposed to be the place where you can see where your neighbor's yard begins and yours ends. It's the property line. So where exactly is your property line now that your fence has been torn in two? And to answer that question, you ask a surveyor. Surveyors use modern-day equipment to try and figure out exactly where everything is on Earth, and they can stake out where your property line is. In order to do that really precisely, they start off with baselines where they look from one mountaintop to another. And in 1906, just after the earthquake, to start this process of rebuilding off, they went up to the tops of different mountains and measured how far different mountains were away from each other. Some of those lines crossed the San Andreas Fault, which is this red line here, and some of them did not. They did some measurements, they figured out where some property lines were, and they came back a couple years later, about 2 years later, long after the earthquake, just to finish some things up. And they took those same measurements to these same peaks, and they weren't in the same place anymore. Everything had moved. This is crazy. Alice Eastwood, our scientist here, tells us, wow, the Earth was moving even after the earthquake. Well, of course the Earth moves during an earthquake, but this shocking realization that the Earth can move even after an earthquake was just an amazing discovery. Because basically what these surveyors discovered was evidence of the motion of giant tectonic plates, the continuous and steady movement of Earth's crust. So they came up with this theory of how earthquakes work based upon this idea. Let's say you've got your fence, you've got your fault, you've got your cow, and over time, the plates are being pulled and dragged and moved, and they want to move, so they start moving. And strain builds up because the fault is stuck. It's locked together because of friction. And strain builds up, and so much until eventually things have to give, and that fault snaps, and the plates pop back into place, releasing a whole bunch of energy that we call an earthquake, that sudden movement along with the seismic waves. And of course, this whole process continues because the cycle of plate motions never stops. We've got plate motion that builds up strain again and again and again until it gets to be too much, and another earthquake. This process repeats over and over again. How does that look like if you look at sort of a semi-real situation? The red line here represents the Anatolian Fault in Turkey, but we can turn it into a little grid. And these yellow arrows on either side represent the movement of the plates. They're trying to move, but the fault is locked along this red line until stress gets to be too much, and it moves quickly in an earthquake. And the blue areas in here represent places where strain has been released, where there's a decrease in stress. The red areas, you'll note at the ends of this little earthquake fault, are places where stress increased, but that's a story for another day.